Hello, very good evening, guys. Welcome to BYJU'S exam prep. Good evening, all of you. Please do let me know whether my audio and video all good, all perfect. All right. So today we're gonna practice some very good level of questions from the engineering mechanics. But before starting with the session, I want to ask you whether all good, all perfect. Yes. Very good evening. Good evening. 1 second, guys. Okay. So how are you all? All good? I hope so. Everyone is fine, and I hope so. You all might be watching match, but ठीक है, for 40 minutes do connect with me because today we're gonna practice some good quality questions from the engineering mechanics subject, and it is a very easy scoring subject. So I want you guys to be consistent for the next 35-40 minutes. I won't be taking a lengthy session because I know everyone will be enjoying the match, right? So good evening, very good evening, good evening. Okay. All right. So before starting the session, how all are you enjoying? All are good, enjoying the your practice session, and how much you have covered? गेट का कितना तैयारी चल रहा है? हेलो हेलो गुड इवनिंग. अच्छा, बिफोर स्टार्टिंग द सेशन, ऑडियो एंड वीडियो में कोई दिक्कत है? इफ एनीवन हैविंग एन इशू, राइट नाउ इन द कमेंट सेक्शन ताकि हम उसको जल्दी से सही कर सकें. राइट. सो हेलो हेलो MS D2E. हेलो गुड इवनिंग, वेरी गुड इवनिंग. 1 second. Yes. Okay. 1 minute, guys. 1 minute. Just give me a minute. Yes, definitely. This gonna be very helpful for your EA because देखो concept चाहे किसी एग्जाम के लिए भी पढ़े, it is definitely gonna help you in all the examination, है ना? Concept you study for any subject, any, like if you studying friction, laws of friction, if you are talking about the rotational motion or curvilinear motion, वो सब आपका हर एक एग्जाम में काम आने वाला है ना? हेलो सुशांत, गुड इवनिंग, वेरी गुड इवनिंग. इसको यहाँ पे रख देते हैं. All set. Very good evening, good evening. Okay, so अच्छा, I was asking you a question. How was your preparation going on for GATE examination? GATE के साथ साथ I hope so everyone is also preparing for the different PSU examination. क्योंकि सिर्फ GATE examination तैयारी कर रहे हैं तो automatically you are also preparing for the PSU examination. And there are 3 PSU which is in front of you right now: HPCL, ISRO, and your BEL. 3 एग्जाम हैं, so definitely it is gonna help you for other examinations also. Right. So chaliye, let's start with the first question on the screen, and I hope so all good with audio and video. And those who are not yet connected on my Telegram channel, you can do connect over here. That is Mechanical by Suraj Gopi. और इस session का PDF I'll be sharing on this Telegram channel. Those who are not yet joined, you can do connect with me on this. Right. This is the Telegram channel that I was talking about. चलिए. And you know that mock test plays a very important role in your preparation journey, right? And this is the list of mock tests that you can definitely should be, or won't say must be, attempting free mock test which is being given by our team BYJU'S exam prep. And at present the second subject wise mock test is going on. Mechanical के लिए, civil के लिए we are having the same thing, right? For differently the different subject, electrical के लिए भी और आपके EC के लिए भी. There are for all the different branches you are having own subject wise test. And after that the last 4 that you are seeing on the screen, these are the full length mock tests already being started from 14th of October. सभी लोगों ने ज्वाइन किया होगा. And those who have not yet downloaded our app, there is a very interesting thing that I want to share with you. App में there is lot many free sessions going on. So I will personally recommend you to enjoy that free interface. You can click on this particular link at the bottom of every session in front of the name of the faculty. Okay, fine. So starting from 6th of November, we will be practicing the early 90s GATE problem, and definitely will be keeping in mind the syllabus of the current GATE, because that time there was some topics which is not being asked right now. So keeping in mind that, we'll be taking some previous year 90s question, because 90s में कुछ ऐसे 2-3 questions थे in that 3 to 4 years of range which was phenomenal questions. Conceptual wise, it was very good. So we'll be taking that set of questions which will be helping you in your GATE preparation journey, right? And if what about this formally memory test, abhi hamara this session is going on. Tomorrow Chandrasekhar sir will be coming up live, then production engineering tomorrow, no, day after tomorrow Chandrasekhar will be coming up live, and production ke sath Dheeraj sir will be coming completing this formula memory test. Chaliye, so shall we begin? Yes, everyone. So first question on the screen. First question on the screen: for a coplanar concurrent force to be in equilibrium, which condition must be satisfied? For a concurrent coplanar force to be in equilibrium, then which condition must be satisfied? Yes. Option A, net force to be equal. Option B, both A and B. Oh, not both A and B, both A and C. And option C, net moment equal to 0, or none of the above. A, B, C and D. Option A, option B, option C or option D. Yes, Sushant, MS, कुछ बहुत ही बेहतरीन लेवल के क्वेश्चंस हैं, but I want you guys to be quickly tell me in the comment section. Yes, first question है. Let me share it also. अभी तक मैंने share नहीं किया है, इसको कर देते हैं share. Okay. First question B. B. Okay, Rohan is going with option B. MS is also going with option B. और कोई? Anyone else? Sushant is going with option A. देखो, whenever you are getting these side of question, try to read the question carefully. They are saying that coplanar concurrent force. Now tell me, if the forces are concurrent, what is the meaning of concurrent force? Concurrent force means the forces are having the same line, the line of action is intersecting at a common point. And we know that when the forces are intersecting at a common point, the net movement about that point is always 0. So do I need to check that movement condition? Not required. Yes, in order to be in equilibrium, then we have to check the total force equal to 0. This condition must be satisfied. Then only we can say a coplanar concurrent force will be in equilibrium. So option A will be the perfect correct answer. Okay? A will be the correct answer. Right? Option A will be the correct answer. Is this clear? ठीक है, देखो ऐसी क्वेश्चन से ना, you will be able to understand the perfect logic. Slightly confusing, slightly we can say conceptual, and in the entire set of today's session I have taken only some conceptual based problem, not a direct formula based. ठीक है, direct formula based एक या दो होंगे, but all the rest of the questions will be slightly conceptual based, some assumption based that you need to understand for understanding the logic. Okay, fine. चलिए next question, question number 2 on the screen. A body rotating with a constant angular velocity will be in equilibrium, will not be in equilibrium, the total force equal to 0, the total have torque equal to 0. Okay, the option D is torque equal to 0. Okay. A, B, C, D. A, B, C or D. A body rotating with constant angular velocity will be in equilibrium, will be not in equilibrium, have net force equal to 0, have net torque equal to 0. Have net torque equal to 0. D, A, D. D, sure, everyone? Everyone, please do let me know, is this, which of the option is correct? Rohan is going with A, Sushant is going with D, MS is going with A. Anyone else who want to respond? Question is very easy. Now tell me one thing. If a body is rotating with a constant angular velocity, chalo, ek example lete hain. Let's suppose there is a body which is rotating in a circular path with a constant angular velocity. Let us say this is omega, right? So what is velocity? V is equal to R into omega. है ना? R is constant. R आपका constant है. Omega is also constant because they have said that angular velocity is constant. So can we say R into omega is a constant value, right? Then what will be the linear acceleration? What is that? Is the rate of change of velocity with respect to time. तो क्या यहाँ पे लीनियर एक्सेलरेशन विल बी जीरो और नॉन जीरो? अगर जीरो है देन फोर्स विल बी इक्वल टू जीरो, देयर इज नो एंगुलर एक्सेलरेशन, देन यू हैव टू टेल मी व्हिच ऑफ, एंड दिस इज एन एमएसक्यू प्रॉब्लम, ठीक है, दिस इज एन एमएसक्यू प्रॉब्लम. मल्टीपल ऑप्शंस विल बी करेक्ट, multiple options will be correct, right? Tell me, if this body is rotating with a constant omega, constant angular velocity, what is the value of acceleration? पक्का sure zero होगा. अच्छा एक बात बताइए, if a body is rotating with a constant omega in a circular path, अगर कोई भी body is rotating circular path, do we have any force being existing? क्या हमारे पास कोई force होता है? If a body is rotating in a circular path, do that body experience any amount of force? If answer is yes, then you should be having an acceleration. बताइए, when the body is rotating about the circular path, yes sir, it is a very important interesting force. That is, what is that force? That is a centripetal force, है ना? That is your centripetal force Fc, which is towards the center. और अगर body में Fc है, we know that according to Newton's second law, if the net force acting is not equal to zero, and we know that net force is equal to mass into acceleration, तो अगर आपका force zero नहीं है, तो body will be having an acceleration, तो body is not in equilibrium, not in equilibrium. Yes, अगर बॉडी में टोटल फोर्स इक्वल टू जीरो नहीं है, then can we say the body is not in equilibrium? Because just now we have said there is a force present, that is centripetal force mv square by r. Then how we can say the body is in equilibrium? Anyone? Remember one thing, what is velocity? Velocity is a vector quantity. It requires magnitude as well as a direction to define. No problem, magnitude is constant. But what about the direction? Direction is constantly changing. Direction is constantly changing, right? So due to this change in direction of the velocity, we are having an acceleration, and that acceleration we call it as the radial acceleration, right? That acceleration we call as, and due to this radial acceleration, we're having a centripetal force being existing. So coming back to this, the body is not in equilibrium. Option B is the correct answer. Okay, fine, fine. The total force is not equal to zero because there is a centripetal force existing, and due to the centripetal force, the body will be experiencing a radial acceleration which will be towards the center. ठीक है, fine, understood, right? Now what about option number D? Is option number D correct or incorrect? Now they are saying that omega is equal to constant, है ना? What is angular acceleration? That is a rate of change of omega with respect to time, है ना? And that will be equal to zero. And what is torque? Torque is equal to I into alpha. So can we say torque is tending to zero? So we can say option B and D is the correct answer. Option B and D is the correct answer. Clear? The body is not in equilibrium, but yes, on the body, the net torque will be equal to zero. Clear hai? B and D, is this clear? Understood? Yes, Rohan, Shushant, MS, all clear? Can we go to the next question, everyone? Clear hai? Logic is clear, है ना? चलिए next question चलते हैं, question number 3, because there are lot many questions and I want you guys to be responding as soon as possible. Okay, चलिए next question on the screen, question number 3. Okay, a solid disk of mass m rolling without slip. There's a solid disk having mass m is rolling without slip, is pulled by a horizontal force at the topmost point, right? And it is moving with an acceleration of a. Then what is the magnitude of the frictional force? What is the magnitude of the frictional force? चलिए बताइए, what is the magnitude of frictional force? Quickly, option A, B, C or D? Option A, option B, option C or option D? फ्रिक्शन फोर्स का वैल्यू क्या होगा? अच्छा, टेल मी वन थिंग, व्हाट विल बी द डायरेक्शन ऑफ फ्रिक्शन एट द पॉइंट ऑफ कॉन्टैक्ट? What will be the direction of friction at the point of contact, left or right? लेफ्ट और राइट, देखो दिस बॉडी विल बी रोटेटिंग इन दिस डायरेक्शन, है ना. सो एट द पॉइंट ऑफ कॉन्टैक्ट द डायरेक्शन ऑफ फ्रिक्शन विल बी लेफ्ट और राइट, equal and opposite. Okay, you tell me the direction, left होगा या right होगा. Yes, देखो how to identify the direction of friction. हमेशा याद रखिएगा, friction always act opposite to the direction of relative motion, है ना. फ्रिक्शन का टेंडेंसी ये होता है, it will always be applied opposite to the direction of relative motion. Yes or no? अब मान लीजिए you are sitting over here, आप यहां बैठे हो on the surface of the disk, आप ऐसे यहां से घूमते घूमते हो, so tendency of this body is to move towards left or right. आप अगर यहां पे बैठे हो इस पॉइंट पे, so with respect to ground you will be moving towards left or right. Yes, आप लेफ्ट की तरफ मूव करोगे, राइट की तरफ मूव करोगे, क्विकली, है ना. You will be having a tendency, because आप यहां बैठे हो, it is rotating in the clockwise direction, you will be having the motion on the left hand side, so definitely the direction of friction over here will be towards right. अगर आप बॉडी पे if you are sliding, देखो अगर if you are sliding, right, if you are having a sliding motion, so on this body the body is moving, trying to move on the right hand side, the direction of friction is towards left. But whenever we are talking about rotational motion, है ना, जब भी हम rotational motion या rolling motion की बात करते हैं, so this body will be rotating like this, right. So at the point of contact the direct friction will be opposite to the direction of motion, relative motion, that is towards right. ठीक है, तो चलिए लगाते हैं concept. So total horizontal force, that is F plus F is equal to M into A. F plus F is equal to M into A. Good evening, right. And let us say this is point O. So the total moment about point O is equal to the moment of inertia about point O, alpha, and that is equal to F into 2R. What is the mass moment of inertia about the point of contact for a solid disk? Mass moment of inertia will be equal to mr square by 2 plus mr square, that is 3mr square by 2. 3mr square by 2. Fine. Very good evening, Mani. 3 by 4 ma. चलो देखते हैं. So we can rewrite this equation. The total moment about point O is equal to F into 2R. F into 2R. Right. This is F. The distance is 2R, and this is your I naught into alpha. So F into 2R is equal to I naught की जगह we can write 3 by 2 mr square into alpha. Right. So from here we can say F is equal to 3 m r alpha by 4, right. Okay, and what is r alpha? R alpha will be equal to A, so we can say this is 3 by 4 m into A. This is the applied force. हमें क्या निकालना है? हमें निकालना the magnitude of the friction force. So let us place it over here. Let us place it over here. So we can say F plus F is equal to M into A, or F is equal to MA minus capital F. So MA minus 3 by 4 MA. So this is equal to MA by 4. This will be the magnitude of the frictional force. MA by 4. Option C is the correct answer. Clear? जो आप 3 by 4 MA बोल रहे हैं, that is the applied force magnitude. Right? Is this clear? Understood. Very good, TPM. Very good. Done. Logic is clear. Simple concept. We have applied the simple two concept. The total force equal to 0. The total force we have calculated in the horizontal direction, that is M into A, and the moment about this point of contact, that is O, that we have calculated, and the moment responsible to rotate this body about point O will be only the applied force, because friction force is passing through the point of contact. Right? So from here I am getting option C, MA by 4 as the correct answer. Done? Everyone? Clear है? Done? Question number 4 चलें. I told you हर एक क्वेश्चन में कुछ ना कुछ आप नया सीखेंगे. You will be learning something new in every question. ठीक है? चलिए next question, question number 4 on the screen. चलिए, if the coefficient of friction is increased, if you are increasing the value of coefficient of friction, then the minimum height at which the body will topple. What will be the minimum height at which the body will topple? Will increase, will decrease, will remain same, or insufficient data? If you're applying a force on a box, right, and the body will be toppling, definitely will be toppling about this point, then tell me what will be, if you're increasing the value of mu, what will be the impact on the minimum height? Will it increase, decrease, or remain same, or it is insufficient data? That means it is not possible. देखो लॉजिक लगाइए, सिंपल लॉजिक लगाइए. If you are moving a box on the road, you are moving the box on the tiles. किस में बॉडी जल्दी टॉपल करेगा? डेफिनेटली ऑन द रोड. सो नो नीड टू अप्लाई अ फोर्स एट अ हायर हाइट. अगर आप बीच में भी फोर्स अप्लाई करेंगे द बॉडी विल बी टॉपलिंग. ऑप्शन बी इज द करेक्ट आंसर. बाय लॉजिक से करिए ना, अप्लाई विद द सिंपल लॉजिक, राइट, है ना. इट विल डेफिनेटली गोना डिक्रीज. द मिनिमम हाइट एट विच द बॉडी विल टॉपल विल बी लीस्ट if you are increasing the friction. Okay, but we'll be definitely talking about the expression also. Okay, expression wise how this is possible. Let us suppose this is the applied force, this is the minimum height at which the body will topple, right. This is the frictional force, this is the normal reaction, this is point O about where the body will topple, and this is the weight of the body, that is W, at a distance of, let's say this total distance is capital small b, and this is height. So we can say the moment about point O should be equal to 0 for limiting condition. For limiting condition, moment about point O should be equal to 0. We can say P into H minimum is equal to W into B by 2. तो यहाँ से H minimum is equal to W B by 2 divided by P. And we know that total horizontal force equal to 0. So P is equal to F, that is equal to mu into N, and your W is equal to N. So let us place it over here. So H minimum, the minimum height will be equal to W B by 2 into P की जगह we can write mu into N, and we know that summation of vertical force equal to 0, N is equal to W. तो ये दोनों get cancelled out. So H minimum is equal to B by 2 mu, and that is I am talking about the static friction. ठीक है. So if you are increasing the value of mu, the H minimum will be decreasing. So that we have seen from this question, that is option B is the correct answer. Option B is the correct answer. Clear है? Right? Option B is the final correct answer. Done? Next question. चलिए, question number 5th on the screen. Question number 5th on the screen. Which of the following statement is or are correct? MSQ question. Which of the following statement is or are correct? चलिए पढ़िए. The moment of force is constant over the length. The moment of couple of force is constant over the length. The moment of force is variable over the length, and moment of couple of force is variable over the length. चलिए. अच्छा ये पूछा था मेंस में फॉर सिलेंडर. ओके फाइन, बहुत बढ़िया, वेरी गुड. ओके क्विकली, what which of the statement is definitely are correct, it's not is, क्योंकि MSQ क्वेश्चन है. Moment of force is constant over the length, moment of couple is constant over the length. So basically they are talking about two statements, उसी को उसने ऊपर नीचे किया है, right. चलिए tell me. It's quite easy. Let us suppose I'm having a rod, right, and I want to calculate what is the, let's say this is a force F. ये आपका point O है, ये point 1 है, ये point 2 है. Let's say this distance is DO, this distance is D1, and this distance is D2. So tell me the moment about point O will be D into F into DO. The moment about point 1 is equal to F into D1, and moment about point 2 is equal to F into D2. If you try to visualize, is all the values same or different? ये सब values same है या different है? The moment of force is constant or variable over the length? We can say M0 is not equal to M1 is not equal to M2. So we can say the moment of the force is not constant, it is variable over the length. it is variable over the same force will be creating different moment over the length. ठीक है सर, बहुत बढ़िया. What about the second statement? The moment of couple of force. ठीक है, let us apply a couple. Let us apply a couple over here. यहाँ पे we are having a force F and we are having a force F separated by a distance of E. This is a couple equal and opposite force acting on a body. And let us suppose this is point O, this is point 1 and this is point 2. Let's say this is XO, right? So the moment about point O will be equal to F into XO in the clockwise direction, right? And F into XO in the anti-clockwise direction, right? Anti-clockwise, that is minus F into E plus XO. So this will be equal to how much? Minus E into F. Okay. Chalo, let us calculate the moment about point 1. Let's say this distance is x1. This distance is x1. Okay. So moment about point O will be equal to F into x1 in the anti-clockwise direction, right? And minus F into E minus x1 in the anti-clockwise direction. When you solve it, you will be getting minus E into F. Yes. Again, if you try to calculate m2 also, you'll be getting minus E into F. That simply means the moment of couple of force will be constant. I can say m0 equal to m1 equal to m2. That simply means the moment of couple of force will be constant over the length. It won't be variable. So B and C is the correct answer. Okay, B and C will be the correct answer. Clear hai? Everyone? Yes, done. कोई doubt है? Any doubt or difficulty you can do, let me know. I told you this all maximum number of questions will be very we can say conceptual. Question में कोई भी doubt होता है तो please you can tell me. Okay, clear? इसमें कलर चेंज हो रहा है. ठीक है, no problem. Done? Okay, all right. Next question, question number 6 on the screen. What is the condition of self-locking in a screw jack? If you're having a screw jack where phi is angle of friction, alpha is helix angle, which of the following is the condition for self-locking? Self-locking क्या होता है? आपने देखा होगा when you are having like in a car, डिक्की में we are having a screw jack. Whenever the tire is being punctured, what you do? You try to lift the car with using the screw jack. And when you are removing that lever, the screw jack remains at that position. As a thought, when you are removing the lever, the complete screw jack is coming down. So definitely there is a concept of self-locking. So what is the condition for self-locking? Anyone? What is the condition for self-locking? Anyone who can help me out in this? Option C. Okay, very good. Option C. और कोई? Very good. पक्का? देखो, whenever now self-locking is required for the lowering the lift, है ना? हाँ, self-locking is required when lower. So whenever we are talking about for the minimum force to lower the lift, it is equal to W 10 phi minus alpha. And I want at least this value to be positive. Body को नीचे लाने के लिए you need to have a positive value. So that means P lower should always be greater than 0. So from here I can say phi should always be greater than alpha. That means the angle of friction should be more than that of helix angle. Option C is the correct answer. Angle of friction should be the higher value. है ना? Very good. Option C is the correct answer. Exactly. No need to apply any force. That is a concept of self-locking in a screw jack from the application of the friction that we have seen. ठीक है? Clear? Understood? चलिए, next question. Question number 7 on the screen. What is the effort required to lift a weight W? एक W weight को lift करने के लिए how much effort will be required in a screw jack? It is basically in a screw jack. In a screw jack. Yes, how much weight will be required to lift a load in a screw jack? Exactly. We can say to lift a load, the effort required to lift a load will be equal to W tan phi plus alpha. Lift करने के लिए we required this formulation option A. For lowering the lift, अगर आपको lower करना है then W tan phi minus alpha. ठीक है? Is this clear? Option B will be correct for lowering the lift. For lowering the load, to lift the load or to lift the weight, you need to apply a force of W tan phi plus alpha. Oh, it is basically minus alpha minus phi, not plus, alpha minus phi. Okay, it is not alpha. In that case, B and A and C will be same. Right? Clear? TPM, Aditya. B will be applicable for lowering the load. A option is basically for lifting the load. ठीक है? Clear? Right? Understood? Can we proceed? Question number 8. Chalo, next question. Acha, before going to the next question, let me give you a quick update. We'll be having a scholarship test being scheduled on 5th of November, right? At 9 AM, and Joshi sir will be coming up live on 8th of November for all the GATE 2025 aspirant. आप लोग 25 की तैयारी कर रहे हैं, definitely you can do attend this session, right? तो चलिए, let's go for the next question on the screen. What is the maximum efficiency of a screw jack? What is the maximum efficiency of a screw jack? Anyone? Yes. What is the maximum efficiency of a screw jack? Quickly. A, B, C or D? Simple question है. 1 plus sin alpha upon 1 minus sin alpha, 1 minus sin, sorry, 1 minus sin phi upon phi is your angle of friction. Phi is angle of friction. बताइए, what is the correct formulation? अब यहाँ बहुत confusion सा होता है. Many students do have confusion whenever they are solving these kind of questions. And these are direct straightforward questions from the screw jag. What is the maximum efficiency? बताइए, what is the answer? Yes, TPM, Shushan. B, पक्का? चलिए, let me help you out in that case. देखो, वैसे तो normally we are having, if I say one second. If I say the efficiency formulation, efficiency of a screw jack is equal to tan alpha upon tan phi minus alpha, right? Phi plus alpha. Okay, fine. And we always try to calculate the efficiency of a screw jack for lifting only, right? And if you try to calculate the maximum efficiency, if you want to calculate the maximum efficiency, right, then we can say, no, this is alpha, d phi. So your alpha is equal to pi by 4 minus phi. Okay? Your helix angle, if I say differentiate and make it equal to 0, if you differentiate and make it equal to 0, then your efficiency will be equal to, one second, this one. Okay, fine. So if you place it over here, then you will be getting the maximum efficiency of the lift will be equal to 1 plus sin phi divided by 1 minus sin phi. ठीक है, अगर आप ये कंडीशन को रखेंगे, that is alpha is equal to pi by 4 minus phi, this is the condition for maximum, condition for maximum efficiency for the lift. तो यहां से आपके पास कौन सा ऑप्शन आया? ऑप्शन ए इज द करेक्ट आंसर. ए इज द करेक्ट. देखो, ये बहुत ही बार स्टूडेंट्स को प्रॉब्लम होता है and they face difficulty whenever they are having this. No, one second. Option B is the correct answer. ये तो हो ही नहीं सकता ना, ये तो हो ही नहीं सकता. क्यों नहीं हो सकता A? You won't be getting option A. There is a technique to remember the formulation also. We know that efficiency won't be having a value greater than 1. है ना? Efficiency won't be having a value greater than 1, right? And if you see option A is having greater than 1, so A and B are the two options which can never be possible. A or B are the option which can never be possible because efficiency will always be less than 1. 100% से ज़्यादा नहीं हो सकता. हाँ, exactly. तो option B is the correct answer. Perfect, perfect. Very good. I was actually thinking something else. Okay. चलिए, done. Option B is the correct answer. Done. 1 minus sine phi upon 1 plus sine phi. By that formulation, we will be getting the maximum efficiency. And this is only applicable to the lift. Lifting के लिए we are calculating the efficiency. Very good everyone. Rohan, TPM, and this way you can try to eliminate the options also. Okay, next question. What's the area moment of inertia of a square about its diagonal? What is the moment of inertia of a square about its diagonal? Tell me. Diagonal के about what is the moment of inertia of the square? Area moment of inertia of the square. चलिए, let's calculate. Let us quickly calculate. And having a side A. Okay, you have to calculate the diagonal. Self locking is only applicable to your this one, lowering the weight, because for lowering the weight you need to apply a force of W tan phi minus alpha. For lifting the load you need to apply a force of W tan phi plus alpha. So there is no negative sign. You will be always need to apply some positive value. It is not possible that you are not applying any force and the body is automatically being lifted up. That is quite not possible. Chali, all the sides of a square is A. So what is the area moment of inertia of the square about its diagonal? Quickly. What is the area moment of inertia of the square about its diagonal? Anyone? Whenever you are having this kind of formulation, try to divide into equal halves. Let us suppose I'm having a triangle, having a base of, what is this? This is A, this is A, this is root 2A, and having a height of, this is A, this is root A, this is A by root 2. Yes? Can we calculate this one? We are having a triangle with a base of root 2A, because this is 90 degree. This is root 2A. Half of this will be your A by root 2. So this is A by root 2. This is also A by root 2, right? Okay. So now we can calculate. We know that for a triangle having a base B and height H, the moment of inertia about the base will be equal to BH cube by 12. BH cube by 12. So let us place it over here. The moment of inertia about base will be equal to, B is equal to how much? Root 2A, and height is equal to A by root 2. Place over here root 2A into A by root 2 whole cube divided by 12. So root 2, this will be 2, 1 root 2 get cancelled. This is A4 by 2 into 12. This is only the half portion. This is only the half portion, right? BHQ by 36 about the base or the centroid? BHQ by 36 is about the centroid. We are talking about the base. This is BHQ by 36. Okay, about the base will be BHQ by 12, right? So this is for half of the section. I need to calculate the double. So the moment of inertia about the diagonal will be equal to 2 times of this, A by 4, 2 into 12 into 2. So this is basically equal to A4 by 12. Option A is the correct answer. Very good. Right? Only I have taken the half portion because I need to talk about the replica at the bottom also. The moment of inertia will be twice that of the base of a triangle. So here we are getting A4 by 12 as the correct answer. Okay, clear? Very good. Option A is absolutely correct. बहुत बढ़िया. Very good. Next question, question number 10th on the screen. Very easy question, direct formula based. A ball is dropped from a height h, will attain a height after n bounce s. We are having a ball which is dropped from a capital height h, right? Then after n bounce or rebounds, what is the height attained by the ball? where A is the coefficient of restitution. बहुत बढ़िया. Everyone, very good. Devesh, Rohan. Yes, TPM, option B. Can we go with option B? Absolutely correct. Option B is the correct answer. इसका simple सा logic है, देखो, there's a very easy logic over here. है ना? If you don't know the derivation, let me quickly help you out. Because it is drop from the initial position, so it will be hitting the floor with a velocity of root 2g capital H. This is the initial velocity, and it will be again going back to a height, let us suppose h1. At this point will be 0. So this is velocity will go root 2g small h1. So we can say coefficient of restitution is equal to velocity of separation, that is v2 minus v1 divided by u1 minus u2. So v2 is body number 2, this is body number 1. So minus of minus root 2g h1, right, divided by u1 is root 2g capital H minus 0. So is equal to h1 by capital H square. Okay. If you try to apply the same formulation, E square is again equal to h2 by h1. So if I try to write h1 is equal to E square capital H, h2 will be equal to E power 4 capital H. So I can say hn will be equal to E to the power 2n capital H. So by this way, we are able to get the simple, very easy formulation. You can directly apply this. Okay, you can use this formulation in the calculations of the collisions of the body. Option B is the correct answer. Chale, next question, question number 11th on the screen. Which of the following is the correct equation of Lagrange's equations of motion? The Lagrange's equations of motion is given by A, B, C or D, where L is your Lagrange function. L is the Lagrange function, right? And Q dot is the generalized coordinate system. Generalized coordinate system. Okay. So tell me, which of the following is the correct formulation of Lagrange's equations of motion? Quickly, do let me know which one is the correct answer. A, B, C or D? Q is the generalized coordinate system. Q, not Q dot Q. Yes, remember? Sir, Lagrange's equation of motion. What is this? Option A, Sushant A, Devesh D. Chalo, likhte hain. A, very good. It is del by del T, del L by del Q dot minus del L by del Q equal to 0. Right? Let us suppose if I want to write this equation in the x direction. Let us suppose in x direction, I can say del by del T, del L by del x dot. X dot means velocity, right? Minus del L by del x equal to 0. What is Lagrange? Lagrange parameter, Lagrange function is equal to the kinetic energy minus potential energy. Okay. Kinetic energy minus potential energy will be giving you the Lagrange's function. So just by getting this equations of motion, we'll be able to create the equation and we can get the solutions of that. Okay, fine. Is this clear? So I think which option is matching with us? Option A. Very good. Option A is correct. Option A is the correct answer. Clear, hai, everyone? Chalo, next question, second last question on the screen, question number 12th. A body rotating with constant angular velocity having a mass m in a vertical plane. So there is a body which is rotating in a vertical plane, right? Having mass m. What is the minimum value of the tension at the lowest point? At the lowest point, what is the value of tension? 4 mg, mg, 0 or 6 mg? 4 mg, mg, 0 or 6 mg. What is the value of tension at the lowest point? The minimum value. Minimum tension means we have to go for minimum velocity, and the minimum velocity to make the complete rotation. What's the velocity at this point? What will be the minimum velocity to make a complete rotation? That is root 5 gr. I hope so everyone knows about this formulation. Root 5 gr is a minimum velocity that you should be having in order to make a complete rotation. Okay, Fine. So now we can say at this point, if I try to do the free body diagram, there's a tension T acting, there's a mg, and the body is having an acceleration of a. So I can say T minus mg is equal to ma, or T is equal to mg plus ma, right? Okay, and we can say T is equal to mg plus mv square by r. So mg plus m into, what is the velocity? Root 5 gr, root 5 gr whole square by r. So this is equal to mg plus 5 mg, that is equal to 6 mg. This is the minimum tension that you can observe at the bottommost point. So option D is the correct answer. Option D. A is not correct, guys. A kaise hoga? The minimum tension at the lowest point is 6 mg. At the topmost position, the lowest value, the minimum value will be equal to 0. The T minimum will be equal to 0. What is the velocity at the topmost point? What is the velocity at the topmost point? What is the minimum velocity that you should be having in order to make the complete rotation? Yes, anyone remember? Okay, previous one. Okay. What is the minimum velocity in order to make the complete rotation? Arey bhai, there are some set of results that you need to remember so as to save your time. Hai na? Yes, anyone? Is it root 3 gr or root 2 gr or root gr? Yeah, simple hai. I want you guys to respond as soon as possible. You can apply the energy conservation. Hai na? You apply the energy conservation. The height is 2r, hai na? mg 2r. We can say this is somewhere around how much? Root gr. Very good. Root gr will be the minimum velocity at the topmost point. Root gr. Here you will be having root 3 gr. Root 3 gr. Okay. So these are some set of values you should be remembering in order to have an upper hand over the other aspirates, right? Okay. Chalo, next, last question on the screen. A horizontal rod released from rest having, not heavy mass, having mass m and length L, the total reaction at the hinge point at this instant is, there is a rod, okay, and there's a hinge point over here, and this body is having a mass mg, this is having a length L. So what is the reaction at this point? Let's say this is point O. They are saying what is the reaction at point O? Anyone? mg by 4, mg by 2, or mg by, it is 3 mg by 4, or option D 0. Option D 0. A mg by 4, B mg by 2, C mg by 4, or 3 mg by 4, or option D 0. Quickly, last question hai guys. Acha, tell me, whenever you are releasing the body, do we have any angular velocity at that moment? Agar is rod ko I am releasing at this position, do we have any angular velocity? Sir, here the omega will be equal to 0. The body will only have alpha, that is angular acceleration. Yahi hoga bas. Jaise when we are dropping a ball, at that moment when you are dropping the ball, the velocity is equal to 0. It only have acceleration, or is action ki wajah se will be having a velocity after some point of time, right? So at this point, which force is responsible to rotate? Sir, this force mg is responsible to rotate. Let's suppose this is point O, and we are having two reactions. Let's say this is R1 and R2, right? As omega equal to 0, can we say here the radial acceleration will be equal to 0? Because AR is equal to R omega square. Because omega is equal to 0, we can say AR is equal to 0. So on this body, we only have one acceleration, that is the tangential acceleration. What is tangential acceleration? That is R into alpha, right? So only AT is present. So we can say the total horizontal force is equal to 0. There is no force acting. So we can say R1 is directly equal to 0. But in the vertical direction, because the body is in motion with a total vertical force mg in the downward direction, r2 in the upward direction. So we can say mg minus r2 is equal to m into at, right? But we have to calculate the value of r2. How we can calculate? Can we calculate the moment about point O? What is moment about point O? So moment about point O is equal to mg into L by 2, and that is also equal to the moment of inertia about point O into alpha. What is the mass moment of inertia of a rod about one of this end? एक rod का जिसका length is L, mass is m, what is the moment of inertia about one of its end? What is this? ml square by 3, है ना? ml square by 3, right? So we can place it over here. ml square by 3 into alpha is equal to mgl by 2, right? ml square by 12 is about the centroid. ml square by 12 is about the centroid or center CG point. I naught, this is point O, it will be ml square by 3, parallel axis theorem. Okay, L and L get cancelled out, M and M get cancelled out. So we are having L into alpha is equal to 2 by 3g, 2 by 3g, right? Okay, not 2 by 3g, something opposite. 3g by 2. Now what is your A is equal to R into, what is radius? Radius is nothing but L by 2. L by 2 hoga radius. So L by 2 into alpha is A, that is the tangential acceleration, है ना? That is tangential. So we can say L by 2 into alpha is equal to 3 by 4 into g, or tangential acceleration is equal to 3 by 4 into g. We got the tangential acceleration value. Now we can place it over here in this equation. We can place it over here. So we can say mg minus r2 is equal to m into at value is 3 by 4g. So यहाँ से r2 की value is equal to mg minus 3 by 4 mg, or this is equal to mg by 4. This is the total reaction at the hinge point. This is the total reaction at hinge point. Okay, so mg by 4 is the correct answer. Option A is the correct answer. Clear hai? Fine, right? Understood? Because r1 equal to 0, there this is equal to 0 because there is no omega. Omega 0, तो यहाँ पे कोई angular AR नहीं होगा. AR is equal to 0, right? We only have tangential acceleration because alpha is present. So by that logic, we have calculated and we got the reaction at this moment is equal to mg by 4. So these are some set of questions which I wanted you guys to practice along with me in this session. So this is it from my side, and we are having the crash course running on our platform, and also those who are targeting 25 and 26 gate, there's a new course being started for the mechanical and also for the civil engineers. You can attend our classes. Okay, you can enroll to this, right? So thank you guys, and I'll be sharing the PDF of this session on my Telegram channel, so do download that and do study from that also. Okay, thank you, bye bye, and I hope so you all enjoyed and got the concept of engineering mechanics, got the feel of engineering mechanics by solving some good conceptual problems. Okay, thank you, bye bye, take care. And those who are joining late, you can do watch the session, it is recorded also, and if you like it, do like this session and do share this video to all of your friends. अगर आपको कोई क्वेश्चन में डाउट आता है, you can do in the write in the comment section, and you can I'll be definitely happy to help you out. Okay, thank you, bye bye, take care, stay safe, enjoy your day with BYJU'S exam prep. Thank you.